Okay, so we have defined our states, and you want to keep in mind what each state means. So each state has associated with it a 5-bit binary number. I only needed 4. Um, I hope you don't need more than 4, because the more states you have, the more work you have. But you can have it more if you want. But we have 5 bits that we're to use for the states. So we have 5 lights to light up, I think, or 5 switches to correspond to it. Since we're only using 4, you can also have a single hex digit. And so the leftmost column here of this table would be the hex digit that if you do the bonus, you can put this state as one of your 7-segment displays. You also have the lane that you're checking. I have here, this says light checked. I should probably say lane checked. Lane checked. There's another modification to this file. And then the state name that I am going to give it in the Verilog, so I can refer to it by a name. It just kind of helps me to have the name rather than just the number. And all of the lanes that have lights that would be turned on are also, you need to have that information too. So now this 5-bit binary number is going to be mapped to your rightmost LEDs. So if you look at your schematic of the board, let me also pull up. So if you look at your board, these excuse me, these rightmost lights, 1, 2, 3, 4, 5, those will correspond to your binary number. So have the 5th one, well, the one that my arrow is on top of right now, have that be your most significant bit. So that's going to be 0 if you're only using 4 bits for your numbers. That one will always be off. And then these next 4 will be will correspond to your state. So for instance, if you are in state 2, which would be 0, 0, 0, 1, 0, if that's the state that you're in, then on your basis board, you would expect these 3 LEDs to be off and this one to be on. Now, if you were in state 3, which is 0, 0, 0, 1, 1, you would expect both of these to be on. So let's see. I also named all my states. I gave them the names state A, state B, and so forth up to state K. I didn't call them A, B, C, D because I used those as parameters for the strings. So you're going to have parameters for the strings of zeros and ones that go to the 7-segment display. So if I want the 7-segment display to display an A, then I used as a parameter the string that has the correct digits to display the letter A. Okay, so what I recommend that you do now is that you get started with your Verilog and you identify your inputs and your outputs. So you would go and you would excuse me. So you're going to say what your inputs and your outputs are. So let's just think about that for a minute, and let's think about what our inputs are. We have our switches, and if you look at what's given to you in your project, let's see. Here we go. So you have all of these switches. So I called the switches XA, XD, XC, XD, XE, XF. And rather than S, I did mode. Just, it was easier. It made more sense to me. S was going to be too confusing to me to keep it separate from the switch over here. These switches. And then reset, load. So these are all still switches. And then S4 to S0, those are switches. You can do that as a vectored signal. So when you put that in, you can do it as input 4:0 S. And when you're putting it in your parentheses for all your inputs and outputs for your module name, you just need to put the capital letter S. Putting it in this order will help you when you define your switches. You want this one to be S4, this one to be S3, this one to be S2, S1, and S0. And those are your rightmost switches right over there. Okay, you also are going to have as an input for right now, for just the most basic functions, you only need the push button clock. You don't need the internal clock for the basic functions, because for the basic functions you're not going to have it run on its own. You'll just need the push button clock. And if you look at lab I said what lab it was in. I don't know. But I copied it here again as well. For the constraints. Those are the constraints. Now, when you copy this, if you copy this from the lab where you used it, it was just called CLK. I changed the name to BTN_CLK to separate it from the internal clock in case I go back and do the bonus, which I may not, because I'm not in this class. You are. And let's see. So those are all the switches. And so those would be your inputs. So now let's talk about your outputs, the outputs that you would need. You need all of these LEDs. So XA through XF for switches that allow you to set what lanes have traffic. YA through YF are lights that tell you which lights are on green. Then you have these 3 LEDs right here that tell you if you're in reset mode or load mode. Or S is going to be for when you have it proceeding automatically. Make sure you give those different names than you did for the switches. So I think I called them reset LED and load LED. It doesn't matter what I called them, but right now you need switches for those things. Let's see, LEDs for YA through YF, LEDs for S, reset, and load, and LEDs for the state. Okay, so your state really is these last 5 LEDs right here. That is your state. So, and I had it in my Verilog. It was just called P, and it was a vectored signal. And because I'm defining it, so it's going to be output reg 40P. I also am defining my LEDs in always blocks, so they're also going to be red. So you'd have output reg YA, YB, YC, YD, YE, YF. So you have those. Your button clock is going to be an input. And again, I just called mine button clock. You're going to have your input. You have your reset, load, and S, which I called mode. And then those I also, if they have LEDs, and those I also defined in always blocks. So it'd be output reg, reset, and I called it reset LED, reset load, and reset mode. Now, mode I don't use in this most basic functions, but I included it anyway to make sure it'd be there if I used it later. You also need to have as output your 7-segment display. Now, it's 7 segments, but it also has a decimal point. So that's really 8 bits. So it's going to be output, and I called it seg. Oh wait, hold on. So output reg. Now I did 0:7 seg. Now I called it seg because that's what it's the name is in the little sample template, constraint template that Dr. Vite made for you, and so that way I just didn't have to change all of the names. You can call it whatever you want. And I did 0 to 7 instead of 7 to 0 because when I need to determine the string that goes with a particular number or letter, let me show you. You can hear the group me in one of my classes going crazy. Okay, so if I wanted to make, say, a 3, is that a 3? That's an E. Okay, so if I wanted to make an E, and I have this picture here, which I have in my Word document, I see that I need segments A, F, G, E, and D lit. When they're lit, they're zeros. When they're not lit, they're ones. And so I am going to want to send to my segment. I had paused it, and I don't know when I paused it, so I don't know what the last thing was that I said. But I'm going back here, and I'm talking about my segment variable that is an 8-bit binary number, and I have it set going from 0 to 7 because seg 0 goes with A, seg 1 goes with B, seg 2 goes with C, and so forth. So for instance, if I wanted the letter E, then the only ones that I would want to be turned off would be segments B right here and C and the decimal point. And so if I just go alphabetically A, B, C, D, E, F, G, and then this is like H, then this is in the order for me. I can do alphabet better forwards than backwards. So so that's the segment. You also are going to have is output reg. Now for the basic functioning, you only use one of the 4 segment displays, but there are 4 of them, and whichever one you use, you can use with your, you set with another string, and it's called AN in the template, so I also called it AN. And where for the basic functioning, you just use the rightmost 7-segment display. So that means anytime you turn it on, that AN is just going to be the 4-bit binary. Oh, I forgot my B. The 4-bit binary number. And you put a 0 in the place of the display that you want it to be. So it'd be 0, 1, 1, 1 to get it to the rightmost display. Alright. Okay, so you need the LEDs for the state, P0 through P4. My cat just jumped up on here. He's probably going to try to walk across the screen now. You need the 7 segments display, which I called seg. You need AN through, this should be AN0 through AN3. So there's another change for me to make. Not a big one, but it's there. Okay, and the push button clock. Okay, now next thing that I would do if I were you is, so you define your inputs and outputs, and I have a copy of this table for you, this diagram for you to use here to remind you. Also, I think it'd be useful to have parameters so that you don't have to refer to things by numbers all the time. So I defined as parameters, I'll just show you. Defined as parameters, so parameter 40, and these were all my states. So I had reset state, and these are 5-bit binary numbers, so those are all my states. So state A, I don't know how big that is on your screen. Oh, also, you'll notice this is real important for it's not an input or an output, but you need to have in there reg40, your next state. The next state is what you compute. This is the logic of everything. How do you figure out what the next state is? And so you need to have a variable name for that, and you'll do that in an always block. So that's going to be listed up here when you do your inputs and outputs and your parameters. And then I also find it helpful to have as parameters your parameters for the letters A through F. So those are the 7-segment strings that I was showing you. So we can just refer to them by A, B, C, D, E, and F. Also had a string for off, where they were all off. Also, I don't know if this is necessary, but I put this in. This it may or may not do anything. I don't know. I guess I could take it out and try. Just to initialize it, I said to initialize it, make P equal to the reset state. And let's see if there's anything else I want to tell you on this video. Oh, right. Okay, so you define your input and output, you define your parameters, and you can do your constraints file. So here's what you'll do for that. So you go to your course, and that's not the right course. Lab resources. Constraints file template. Okay, so you have here everything but the button clock. So the button clock, that's in your labs. I also have it on my document. If you go back and do the bonus, you'll need the clock signal. So you'll get these switches here. So you'll take all of these switches, Control C. And then when you do your constraint file, let me just make a new project. Okay, so I'm going to make a new constraints file. I'm going to give it the creative name, Project Constraints. Okay, now I can copy those in. Now, a handy feature, I want to uncomment all of these. There's this button right here, I can uncomment them. I can take out the ones I don't need, which were the middle two. I don't remember which those were. You can find those yourself. And you need to put in the correct name for your switches. So, like for instance, here we go. So R2, well, V17 is S0. Okay, so you got that. And then V16 will be S1 and so forth. And you can take out the ones you don't need, which since I have it here, let's see, it was in between T2 and W3. So it would be I may have something wrong in my diagram. I'm not going to worry about it. You can figure that out. Okay, and then also you get your LEDs. So you can copy your LEDs, and you'll put the correct names on your LEDs. You can copy your 7-segment display, and then you'd want to rechange. You want to change this decimal point to seg7 if you're putting them all in together like I am. You'll need these ANs. And I think that's all you need for your constraints. Okay, so that's all I want to say on this video.